Okay, lesson 98, part 2. Here we go. Scale factor we can use on these three-dimensional shapes. However, you have to remember that it's linear measures only and not area or volume. And we can choose now any of the corresponding sides and put our little factor in there, right? So I chose 2 is what factor of 6? Well, I get 3 because 2 times 3 is 6, right? I mean, that's pretty easy. So that's how you can get the factor. Here's my little happy thumb. Therefore, because it's a factor of 3, therefore the area of any face of the larger cube is going to equal 3 squared equals 9, or 2 squares, right? So 9 times any measure of the larger cube. So we have 9 times 6, which would be 54 centimeters cubed. So 9 times 6, look, we're just doing this, right, equals 54. So the smaller rectangle face of the area of the face would be, what, 2 times 3. So you would get 6 centimeters squared. So 9 times smaller than the large box. So volume should be 3 to the 3rd power, or 27 times greater, because this was 3, what's area? 3 squared, what's volume? 3 cubed, so 27 times the volume of the smaller square. So let's check it out. We can just take all of our numbers, so the larger one comes out to 648 centimeters cubed. The smaller is 2 times 3 times 4, which is 24 centimeters cubed. Well, let's just see if 24 times 27 is 648, and ta-da! It is. So, yep, that works. We could have also shown it like this. Put our coordinating sides above each other. So you got 6 over 2, 9 over 3, 12 over 4, cross cancel, cross cancel, cross cancel, cross cancel. What do you get? Well, you get 3 cubed. Right? So I can cross out all my like labels, and I can do all of this cross canceling, and I end up with 3 cubed. So there you go. All right, practice set. I want you to copy these down so that we get it in our head. All right, so a blueprint scale is 1 to 24. The length of a wall on the blueprint was 6 inches, so what's the length of the actual house? Well, I need to know. My scale factor I already have is 1 to 24, correct? Oops, sorry, I keep moving the thing. So if we need to find the actual size, what are we going to do? Well, one way we can do it is 6 times 24 divided by 12. So that's the way I can get right away to feet instead of having to do my unit multiplier. That's what it's called. Jeepers creepers. Okay, so what's 6 times 24? I don't know. 24 times 6. 4, carry the 2, 12, 13, 14. Divided by 12. 12 goes into 144. I happen to know 12 times. So this would be my answer. Or I could have done, okay, 1 is to 24 as 6 is to what? And then done my cross canceling, and I would have had x equals 144 inches. See? And then I would need to change it to feet. So I'm going to do the same thing. I cross out my inches label. I'm left with only my foot or my feet label, and I would still end up with 144 divided by 12, which would be 12 feet. Okay? 2 different ways, same answer. Oh, circle your answer, Mrs. Van Zalen. Okay. Well, let's do another one. A model ship with a scale of 1 to 36. If the ship is 54 feet long, the model ship should be how long? Well, let's do it this way. We got 1 to 36. I don't know what my model should be, but my actual ship is 54 feet. So I'm going to cross multiply, so I get 36x equals 54 feet. If I multiply or divide that in there, I get 1.5 feet. But if we wanted to convert it to inches, we would just do this, right? I get rid of my foot and my foot over here, so 1.5 times 12, or 12 times 1.5, you get 18 inches, okay? Or we could have put 54 over 36, 12 over 1, done all of that, and we get 18 inches. Why 12? Because there are 12 inches in 1 foot. So really you're thinking, okay, this is 12 inches, this is 1 foot. And if I do it this way, it's kind of done in 1 step instead of the 2 steps. I like this better myself, but it's up to you. It's up to your brain. All right. We're going to do practice set. I'm going to do some of these, and then you're going to do some of these. So in this one, I just want you to think, well, wait a minute. Instead of doing all this cross multiplying and then dividing, what did I multiply 5 by to get 15? You multiplied it times 3. Yes, I did. So if that was multiplied by 3, I can take 7 times 3, so W equals 21. Okay? It can be that simple. All right, here's another one. 3 something over 3 equals 42 over 21. Well, these are going to be equal, right? So it's as if this has not been reduced. So 3 times what gave me 21? 7. So what's this x going to be? It's going to be 7x, right? Or just, no. This is going to be 6. Sorry. It's going to be 6 because 6 times 7 is 42. Mrs. Van Zeelen? Yoy. All right, here's another one. I better find out where this is from because I wrote this yesterday. Uh-oh, hang on. All right, we have 2 rectangles that are similar. Calculate the scale factor from the smaller to the larger. All right, so I'm going to take coordinating sides. So I'm going to take 4 and 10. This is 10. So I'm going to say 4 factor of 10. So F will equal what? Well, 4 can go in there 2 times 2.5. So it would be 2.5. Did you get how I did that? Let's do it again with these up here. What if I did 10 factor equals, what's the coordinating side? 25. So F equals, how many times does 10 go into 25? Oh, magic, 2.5. So it's the same. Now we're going to take the area of the rectangle is how many times the area of the smaller. Well, we have to figure that out, right? So we need to, so we need to think to ourselves, we can do it 2 different ways. We can divide the area of the larger rectangle by the area of the smaller rectangle. So let's do the area of the smaller rectangle is 40 divided into 250. Let's just divide by 10 a minute. And then 4 go into 25. Let's do it up here. You can go in there 6 times. You'd get 24. You would get 1 at 0.2 gives you an 8. It gives you 25. All right, so doing it this way, I get 6.25. The area of the larger is 6.25 greater than the smaller. Or you could square the scale factor. Here's the scale factor because we want the area, right? So look at this, 2.5 squared. So that'd be 2.5 times 2.5. You get a 0, you get a 10, you get a 5. And look at that, 6, 2, 5. How many decimal places is there? 2, 6.25. Oh, it's another Christmas miracle. They are the same. So it just depends on how you like to do it. Okay, so on this one, they want you to graph it. For every 1 inch, I have 36 inches. 36 inches is really going to be 3 feet. So I have my model in inches, my actual size in feet. So if I were to do that, I would say, okay, 1 inch equals 3 feet. Oops, come on. Why aren't you working, pen? Okay, well, there it goes. Then that would mean that 2 inches would be 6 feet. Go over here. And on and on and on, and you would get this really beautiful line that goes like this. Just pretend it's straight. That's terrible straight. Not straight at all. There, that's more better. All right, so imagine a line going straight like that, and all of these would fit this 1 inch to 3 feet. Trust me. If we have questions, ask me later. Like in class. Okay, quickly, your assignment. 1, 4, 5, 6, 9, 12, 15, 17. Do be first of 17. Excuse me. 19, 20, 21, 22, 23, 24, and check. 25, and check. And 30. Did I give you the secret word already? It's scales, right? Oh no, it's fish. Because fish have scales. So remember, secret word, fish. Whew. All right. See you in class.